Hello, this is question 19 on paper 2 of TMUA 2017, and for this question we want a sufficient condition for this cubic to have exactly one real root. Okay, so for cubics we don't have a really convenient formula for working out the roots like we do for quadratics, so we're going to have to think more about what the graph is going to have to look like for this cubic to have exactly one real root. So we've got x cubed with a positive +1 coefficient. For this to have one root, either it can look something like this, or it can look like this. And you can see for both of these, either we have both of the turning points above the x-axis, or both of the turning points below the x-axis, and therefore that's a necessary condition for having exactly one real root, the turning points either being both above or both below the x-axis. Okay, so let's work out for which area we're going to get the turning points both on the same side of the x-axis. So if we differentiate our cubic, we're going to get our quadratic as 3x squared minus 6x, and then setting our derivative to 0 to find the turning points. 3x squared minus 6x equals 0 gives us either x equals 0 or x equals 2. And now if we substitute x equals 0 and x equals 2 back into our cubic to find the y values of our turning points, when we put x equals 0 into our cubic, we get that y is a, and when we put x equals 2 in, we get y is a minus 4. And so if we want our turning points to be either both above or both below the x-axis, then we're going to need both of these y values to be either both above 0 or both below 0. Okay, so let me rearrange this to give us a bit more space. Okay, so if we take the 4 to the right-hand side of these second inequalities, then we can see that they're the same as a greater than 4 and a less than 4. And now, if a is greater than 4, then a is definitely greater than 0, right? So for this first condition, we could just specify a greater than 4, and both of these would be satisfied. And similarly for the second one, if a is less than 0, then a is definitely less than 4, right? So the second condition is just the same as specifying a is less than 0. Okay, so these are the necessary conditions for our cubic to have one real root. So for this cubic to have one root, we're going to need either a greater than 4 or a less than 0. And if neither of these are satisfied, then we won't have exactly one root. So now we just got to figure out which of these conditions will make sure that one of these or both is satisfied. Okay, so for a greater than 0, well, no, because a could be like 1 or something, and then neither of these would be satisfied, so that's not sufficient. If we specified a less than or equal to 0, well, a could be equal to 0, and then they wouldn't be satisfied. And similarly for a greater than or equal to 4, a could be equal to 4, so this isn't sufficient either. A strictly less than 4, well, again, a could be like 1 or something, so that's out. For the absolute value of a to be greater than 4, either a is greater than 4 or a is less than minus 4. And we can see that that would be enough to know that these conditions are satisfied. A greater than 4 or a less than minus 4 would definitely give us that a is less than 0. So we know that if this is satisfied, then our necessary conditions are satisfied. Therefore, the absolute value of a being greater than 4 would be a sufficient condition.